I really like the RP2040's form factor from Waveshare, and they have a new RP2350 now too, in the same form factor. The small boards and of course that USB-C are great. There's one problem though, no SWD port. So how do I do debugging on my production PCBs? My answer is to make a Pico or a Pico 2 look like the RP2040 or RP2350 with the help of PCBWay. Let me show you how I did this. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, Pico 2, robotics and other fun tech. Remember to subscribe and join the community. I've talked about the RP2040 on the Debug probe video, as they're the boards I frequently use as a Pico probe for flashing and of course UART proxying to my Mac. It's on my current robot project that I've looked to use these boards in a more production setting. The size of the boards is ideal for me to hide them close to hardware like the motors and sensors. But sometimes my code misbehaves and I miss having SWD to control it and see what's going on, including flashing it. In this video, I'm going to produce a daughter board which has the RP2040's male socket, but is using a Pico or a Pico 2 to provide the GPIO pads. Therefore, I have SWD port for debugging on the Pico or Pico 2. The board will be fabricated for me by the video sponsor, PCBWay. If you like this video and it helps your learning or projects, why not drop me a cash tip using the super thanks button below the video or the payment link in the description below. I'm saving these up to get myself to the open source conference in San Francisco, and I'd appreciate your help in getting me there. And I'd love to see you there too. Please hit the like button on the video and subscribe for more. This video is sponsored by PCBWay. Projects like this are not possible without a PCB fabricator. This is always going to be a low volume production, as I'm only ever going to need one or two of these boards. The perfect project to try out PCBWay's production services. PCBWay make the ordering of the PCB easy. They check for production issues and ship it to me in around a week, giving me time to share the project with you. So why not go and check out PCBWay after the video, of course. I really like the RP2040's form factor. The fact that it's actually about half the size of a Pico or Pico 2 is really great, and that upgrade from the rather fiddly micro USB connector to a USB-C is also a great advantage for me. You have to be a little bit more careful with these because on the back of the board they've still got a whole load of electronic components. In fact, the RP2040s actually are on the underside of the board. You shouldn't really rip them off your circuit board using a screwdriver, as I sometimes have done with Picos. The pinout gives us access to most of the GPIOs we're used to on the Pico and Pico 2, either on those two vertical connections sets either side, or on the bottom there are a further 5 connection and GPIOs. In fact, on the underside there's also some touch points that you could use to tap off to some additional GPIOs. Not that I've ever been clever enough to do that. So when I'm using these on a breadboard, I actually just solder up the two connections either side, and that way I can just clip it onto a breadboard nice and easily. In this project that I'm working on at the moment, I actually need slightly more GPIO outputs than that, so I'm going to need those 5 at the bottom as well. So all of those are going to be soldered up, and that means I'm going to have to mimic all of those. The whole point of this project is giving me an SWD port for debugging, so that I can simulate my RP2040 in circuit by using my Pico. So of course need that SWD port, and of course I need the pinout somehow of my Pico to magically get to that U shape of the RP2040. Now I'm going to add some stuff on this, so I will add an LED for power, just to make me sure that actually everything's connected and working okay. And I'm going to have two other LEDs that I'll optionally allow myself to connect in, one on GP21 and one on GP22. Plus I'm going to allow myself a reset switch, because I really do need a reset switch. They come actually pre-built on RP2040 Zeros. In my design of this and my initial requirement set, I forgot something. I forgot that RP2040 Zeros have a WS2812B LED on GP16. And they can then set that to various colors using using WS2812B controls. Now I would like to have that, and indeed I have got that on my production version, but I've done it by just tapping off of a connection on the board rather than actually laying it out properly, because I forgot that I needed it. Sorry. So the finalized board is going to look something like this and just be able to plug in. We'll talk about that a bit more after I've talked about the design. So I'm going to design the board using KiCad, which is my favorite PCB design pieces of software and open source too. All of the design I'm going to share on GitHub, and you can find it as usual with my code. It's over here on this repo. I know the schematic editor in KiCad doesn't come across very well in screen capture, so I'm going to keep the images quite large if I can, and we'll see how we get on. And yeah, I'll keep this fairly brief as well. So all we've really got here is the schematic for how I set this up. So the first thing I really did was actually create this socket symbol for our RP2040 Zero, and you know, I can basically just pull in an RP2040 Zero and use that as my socket for it, which is really quite easy to do. And I can pull in my my Pico as well. Then all I'm really doing is setting up labels for each of the labeled nets for each of the connections, so GP0, GP1, etc., so that I can map them across between the two devices. Then I'm going to add in things like my reset circuit up here, and over here I can add in nice things like my LEDs. So I might really want to actually use GP22 and GP21, so I've not fixed them to the LEDs. They're going across via jumpers, so I can always disconnect them if I wish to do so, and jumpers are just 2-pin header pins, which then I can just bung a jumper on. So yeah, that's it. The other thing I would say that I didn't talk about in my requirements is I am actually going to also expose all of the GPIO pads. So I'm basically going to put 2 rows of 20 header pins so that I can pick off anything. And that got me over my little problem of forgetting that there is a WS2812B on GP16 on a RP2040 Zero, because I can now just pull that off of GP16 anyway, just off of the header pins. Originally I thought, well, there isn't much on this board. There's just the microcontroller on its socket and 3 LEDs and their associated resistors and a switch. I could make this as a 2-layer board, surely. But actually, when you look at the connections that are going across between the Pico here and the socket, actually you start realizing there's no way you're going to be able to do that as a 2-layer board. There's just way too many connections going across there in too small an area, so it is actually a 4-layer board. But yeah, all fairly tightly laid out, or as tight as I could get it, trying to keep the socket area quite free so that I can nicely slide that into any of my projects. And then we've got the main board up here with the Pico, 3 resistors under there to drive the 3 LEDs, the reset switch, and a couple of jumpers for the LEDs to enable this second and third LED. So that's it really. Now Obviously it should have a WS2812B LED up there on GP16, though well, if I ever do another version of it, it will be there. PCBWay came through with a lovely board. You can see the front on the left there and the back on the right, and I was able to solder that up, put my Pico on it and connect it to a debug probe to give me a perfect development platform for simulating or mimicking my RP2040 in my production circuit, which is really fabulous. Okay, you can see the WS2812B LED hanging off a bit of wire there because I forgot it. Sorry, I'm annoyed about that. Anyway, it all works. It does exactly what I needed it to. Gives me access to debug and speeds up my development while I go through that transition from, you know, concept and breadboards through to actually getting code to run and be part of my production service, which in this case is a robot. So boards like this, which is one of the robot's control boards, this actually is going to be associated with a wheel, and it's going to do everything from motor control through to some temperature sensing, some ultrasound distance sensing, and some there's some WS2812B LEDs that I actually remember to wire on this board. So all of that's on there, so it's got quite a lot of stuff on quite a tight area, and using this that Mimic board, I'm able to actually really debug everything and make sure that everything actually works together, which is really helpful in my development process. With the one exception of GPIO29, this board lets me fully mimic an RP2040. So having a daughter board isn't perfect. You'd never run this in production on the daughter board, but then you would never be running a debugger like GDB against the SWD port in production either. So generally, I think this is a neat solution for my builds. It helps me in the transition from breadboard to full production system. If you like this video and it helps your learning or projects, then why not drop me a cash tip using that super thanks button below the video, or the payment link I've put in the description. Remember, I'm saving these up to get myself to the open source conference in San Francisco with the other makers, and I'd appreciate your help in getting me there, and I'd love to meet you there too. Thank you very much for watching. Please subscribe and like the video, and I will see you on the next video. Bye bye for now.